Yes. Mhm. Yes. Mhm. Yes. Mhm. Yes. Mhm. So, good evening, all of you. So, this is our what practice session. In those 3 days, 4 days, we have completed what? We have completed universal particle physics in detail, nanotechnology, space technology, and nuclear technology. So, basically, I have designed this 40 questions. These 40 questions they have been designed in accordance with the UPSC pattern itself. We will be solving all these important 40 questions. Is it okay? So, please join the session. Okay. So, first question is about with the development of semi-cryogenic engine by the ISRO, how do they differ from the full cryogenic engine? First is semi-cryogenic engine uses refined kerosene as a fuel instead of liquid hydrogen, though both use liquid oxygen as the oxidizer. Semi-cryogenic engines are generally more economical and easier to handle at the ground level than fully cryogenic engines. Semi-cryogenic engines offers a higher specific impulse than the liquid hydrogen based cryogenic engine. Okay, so we have discussed that what is semi cryogenic engine. Okay, for example, if you talk about like GSLV, geosynchronous launching vehicle, it comprises of 3 different stages. First stage, what we will have solid propellant. Second stage, what we will have liquid propellant, and for that purpose we will be using Vikas engine. And finally, what we will have cryogenic propellant, and for this purpose we will be using C20. Now we have discussed that when you talk about the geosynchronous launching vehicle, its payload capacity is how much? It is limited to 4,000 kg. That means what? It can place a satellite of weighing 4 kg in geosynchronous orbit. Okay, but now little bit changes. Now when you talk about the semi cryogenic engine, here what we will have, here in the GSLV, in the first stage we will have solid propellant. In the second stage, instead of using liquid propellant, we will be using what? Semi cryogenic propellant. Semi cryogenic propellant. Okay, semi cryogenic propellant. And finally, we have cryogenic propellant. Okay, so when you talk about the semi cryogenic propellant, what it is, we know that when you talk about the cryogenic propellant means what? We convert hydrogen gas into what? Hydrogen liquid hydrogen. And what is the temperature that is being required? Minus 253 degrees Celsius. And similarly, for the purpose of oxygen, we will take the oxidizer. So oxygen gas, it is being converted into minus 183 degrees Celsius into liquid oxygen. Is it okay? So this is your cryogenic propellant. Now semi means what? On we will take, instead of using liquid hydrogen that has to be converted using cryogenic technology, you will be using what? We will be using cryogenic kerosene fuel. We will be using kerosene. We already know that when you talk about the kerosene, it is what? It is already the liquid state, and apart from that, we will be using what? Liquid oxygen. So obviously, for the purpose of converting gaseous state of oxygen into liquid state, we will be using cryogenic technology. So here you can see that this becomes the propellant. So only half, when you talk about the oxygen, it requires cryogenic technology, but kerosene it is available. Okay, so from here you can see that semi cryogenic engine uses refined kerosene for fuel instead of liquid hydrogen too, though both uses. Second, what? Semi cryogenic engine is generally more economical. True. Semi cryogenic engine offers higher specific impulse than liquid hydrogen based. This statement is wrong, because when you talk about the hydrogen already we have discussed in my classes that when you talk about the hydrogen, its calorific value is much more higher than the kerosene. Is it? And so because of this statement is wrong. So answer will be what? 1 and 2. And apart from that, what is the why we are talking about the semi cryogenic engine or semi cryogenic propellant? Obviously the semi cryogenic propellant, it will be requiring semi cryogenic engine, because we see that when you talk about the GSLV, it is limited to how much? 4,000 kg. But instead of using liquid propellant, if you start using the semi cryogenic propellant, it weight carrying capacity will increase. It will become how much? 6,000. What? 6,000 kg. That means what? If instead of using liquid propellant, if semi cryogenic propellant it is being used, what will happen? The weight carrying capacity of GSLV, it will be enhanced. How much it will become? It will become 6,000 kg. Is it okay? So answer will be 1 and 2. Now, second, with reference to the site selection criteria of the Event Horizon Telescope, we have discussed this in our classes. Event Horizon Telescope consider the following statement. Okay, so first of all, when you talk about the Event Horizon Telescope, it comprises of total how much telescope? It comprises of 8 telescope. First point. Second point, what we have seen, 6 of the telescope. 6 telescope, they are being placed on the western part of the continent. On the western part of the continent. Why so? Because this western part of the continent, they are under the continuous influence of cold current. So obviously, because of this cold current, they have what? Desert. Desert. Is it okay? Why desert? Because we have discussed that when you talk about the water molecules, they will capture the infrared. Suppose if some celestial object, they are releasing infrared. So if there is a water molecules, what will happen? Those water molecules, they will absorb this infrared. And because of that, when we try to go for the establishment of telescope, we see those positions where we do not have water molecules. So obviously, it's the desert. It's the cold desert, for example, Ladakh. And because of this, you can see that when you talk about the Event Horizon Telescope, they are being placed on the western parts of the continent at higher altitude also, so that we do not have atmospheric interference. So with this, we'll see, are we able to solve the question? Stations are predominantly located at higher altitudes to minimize the atmospheric blurring caused by the thickness of troposphere. This is true. Second, what? Extremely dry conditions are prerequisite because water vapor in the atmosphere absorbs and scatters the millimeter wave. Millimeter wave means what? Here we are talking about infrared waves. Infrared. Okay. So we have discussed that water vapor, they absorb these waves, and because of this, we have developed this as Event Horizon Telescope on the western part of the continent, so that because of the cold current, what? We have deserts over there. This is also true. Now, Event Horizon Telescope requires sites with high mutual visibility, meaning multiple stations must be able to view the target black hole simultaneously to function as an Earth-sized virtual telescope. In the classes, I have discussed that those 8 telescopes, they are positioned in such a fashion that they form an virtual optical mirror, and the diameter of the virtual optical mirror is what? Equivalent to the Earth size. So this statement is also true. So it will be a 1, 2, 3. Okay. Dear students, please do comment. Read the questions once and please do comment, so that what? The session can be an interactive one. Is it? Okay. Next question. Neutron degeneracy pressure originates from which of the physical principle, which and why does it fail during black hole formation? The Heisenberg uncertainty principle, it fails because the core volume becomes infinite. The Pauli exclusion principle, it fails because at extreme masses, gravity overcomes the quantum resistance of the neutrons being packed closer together. Is it? What will be the answer? Please do comment. Question number 3. C. General relativity, it fails because space-time curvature prevents particles from interacting. D. A strong nuclear force, it fails because the neutrons begin to decay in the quarks at leptons at higher velocities. What will be the answer? B. Okay, very good. Okay, so what we have discussed, that when you talk about the smaller stars after their death, stars after, or when you talk about the stars, okay, in case of a smaller star, what? It will go planetary nebula, and after that the core that is being left, we are talking about this core. If the mass of the core, if it is less than equals to Chandrasekhar limit, what will happen? it will become white dwarf. It will become white dwarf. That means what? We have discussed that when your nuclear reactions are stopped, what will happen? The core is only under one force, that is inner gravity force, and this inner gravity force, it will try to squeeze the complete mass of the star, but it is being restricted by electron degeneracy pressure. In case of white dwarf, I have explained, in case of white dwarf, this white dwarf is formed because what? Why? Because of electron degeneracy pressure. Electron degeneracy pressure. But in the case of larger star, what will happen? After supernova explosion, what will happen? Supernova explosion, the core that is being left, obviously, in case of neutron star, the size is higher. It is equivalent to what? 2 to 3 times the mass of the sun, and because of that, we will have higher inner gravity forces. Now, those inner gravity forces, what they will do? They will what? Compact those electrons. Those electrons, they will be coming into the nucleus, and now because of that, one pressure, it will get developed, because that is called your neutron degeneracy pressure. So when you talk about the larger star, for example, it will get converted into neutron star. Neutron star. Okay, so this neutron star, they are being formed because why? Because we have a pressure called your neutron degeneracy pressure. But in the case of more larger star, if it crosses tau limit, Tolman, Oppenheimer, Volkoff limit, what will happen? The inner gravity forces become much more dominant, and because of that, what will happen? It will easily cross this neutron degeneracy pressure, and finally, even a stage will come that is called the quark stage. The quark transient stage, it will also overcome, and because of that, all the masses, they will get converted to a point called singularity. So this is a neutron, and I have discussed in my classes that both this electron degeneracy pressure and neutron degeneracy pressure are in accordance with what? Pauli exclusion principle. Pauli exclusion principle. Okay. So answer it will be 2. Okay. Second. Question number 4. Please solve this question and do let me know. Question number 4. What will the answer? In the context of high energy astrophysics, why is atmosphere play in this process? Okay. First, the radiation is produced by the telescope on mirror as they move as relativistic speed through the air. The statement is wrong. Second, gamma rays are reflected by the upper atmosphere, and the mass telescope capture the reflections as Cherenkov pulses. The atmosphere acts as a giant calorimeter and transducer where the primary gamma rays are converted into detectable light through the particle shower. Answer, it will be what? C. Do not get confused. Okay, answer kya hoga? It will be C. Why so? Because we have discussed that we in the Ladakh itself, what we are developing? Mace telescope. Now this telescope, it is being designed to capture the gamma ray burst, but since gamma ray burst, they are the highly energetic process, they cannot be directly captured by this mesh telescope. So what will happen? Suppose here, this is the mesh telescope, here we are having what? Atmospheric region. So when the gamma rays, it will strike the atmosphere, what will happen? Here we have nitrogen and oxygen molecule. Since gamma ray, that is for higher frequency, and because of that higher energy capacity, they will strike the nitrogen, they will strike the oxygen, and because of that, what will happen here? Electrons and protons will get ejected. Electrons and protons, they will get ejected. Now these electrons and protons, they will be moving with the speed that is greater than the speed of light, and this is called your what? Cherenkov radiation, and this is called your Cherenkov radiation. Is it okay? So here you can see that the atmosphere acts as a giant calorimeter and transducer where the primary gamma rays are converted into detectable light through the particle shower. Okay, so ultimately what? This is what? Electrons, protons that is generated because when your gamma ray, it will strike the atmosphere. These electrons and protons are nothing but they will become the particle shower, and at that point of time, what will happen? They will be moving with the greater than the speed of light, and this is how it captures it. Okay, so answer it will be your C answer. Is it okay? I have discussed this in my classes. Okay, so answer, it will be a C. Okay. Question number 5. With reference to the NASA ISRO With reference to the NASA ISRO synthetic aperture radar mission, consider the following statement. It is the world's first dual frequency satellite mission to employ both L-band and S-band on a single platform. The mission utilizes a novel sweep SAR technique to overcome the traditional trade-off between high image resolution and wide area coverage. While the L-band radar is contribution of NASA's Jet Propulsion Laboratory, and S-band and GSLV launching vehicles are indigenous contribution from the ISRO. The primary scientific objective of NISAR is to monitor global surface changes with sub-centimeter accuracy, specific disaster management and cryospheric studies. What will be the answer? Question number 5. Question 5. This is your question 5, all the statement. See, we'll discuss question 5D. Please mention 5A, 6A, something like that. Okay. So here you can see we have discussed about the NASA ISRO NISAR mission. Okay. So here we are using what? Two frequency band, L band and S band. True. The mission utilizes a novel sweep SAR technique to overcome the traditional trade-off between the high image resolution and wide area coverage. Since we are using the sweep SAR, it can cover what? It can give you the high resolution also, and at the same time it will be covering what? Huge area also. This statement is also true. Now this is also true. L-band it is being provided with the NASA, and S-band and along with the GSLV launching vehicle, it comes from the ISRO. And fourth is what? The primary scientific objective of NISAR is to monitor global surface changes with sub-centimeter accuracy, specifically disaster management and cryospheric studies. Okay, this is important. We have discussed that when you talk about the NISAR, that means what we are using? Synthetic aperture radar. This particular mission, it has basically been developed so that what we can measure what? Glacier retreat, we can measure what? Cryospheric, we can measure what? Sea level changes. And here is the term cryosphere. So ultimately all the four statements, they are correct. Clear? Okay. Question number 6. In the context of India's recent space mission UNVASE, we have discussed. Please do reply in the form of 6A, 6B, 6D, and please do participate. Okay. In the context of India's recent space mission, the UNVASE satellite is often discussed. Which of the following statement best reflects its analytical and strategic importance? It is India's first dedicated satellite for the detection of gravitational waves in the low Earth orbit. It serves as a technology demonstrator for a plug-and-play modular satellite bus using hyperspectral imaging for both civilian and strategic surveillance. It is a joint venture between Israel and European Space Agency. It is primarily designed to test nuclear thermal propulsion system for future deep space mission to the Mars. Question number 6. 6B. Yes, very good. See, when you talk about the UNVASE mission, okay, there in the UNVASE mission, what? No doubt the mission is being particularly failed, but we have discussed that this particular mission is called what? A spy mission. Why so? Because it is using what? Hyperspectrum. It uses what? Hyperspectral imaging technique. It uses what? Hyperspectral imaging. Okay, and this we have discussed about the SAR, synthetic aperture radar, and we have also discussed about hyperspectral imaging. When you talk about the hyperspectral imaging, it can capture. It's a what? Passive imaging technique. Passive. It's a passive imaging technique. That means what? It means this particular sensor, it won't have its own light, rather it is going to capture the reflected light. Okay. Second is what? When it captures the reflected light, the frequencies, it captures a broad band of frequencies. It captures what? Broad band of frequency. It captures narrow bands of frequencies. Narrow bands of frequency. Narrow band means what? Because it can capture even slightest change in the frequency, and because of this frequency, it can exactly ascertain the composition of the material. That means what? Suppose it's called a spy mission. Why? Suppose in the forest cover, if certain equipment they are hidden, camouflaged equipment that can be detected with the help of UNVASE, and because of that, here you can see that it serves as a technology demonstrator for plug-and-play modular satellite bus using hyperspectral imaging both for civilian and strategic surveillance. Okay, a spy mission. Okay, but rest of the things, they are non-relevant. Question number 7. Go through it. Question 7. Okay. Go to the question number 7. Again, with reference to the unmanned satellite mission launched by ISRO, consider the following statement. First, UNWAYS utilizes hyperspectral imaging, which captures data in hundreds of narrow, contiguous spectral bands across the electromagnetic spectrum. First. Second, the spectral fingerprinting capability of UNWAYS allows for the detection of camouflaged military hardware by identifying the chemical composition of the material rather than just by visual appearance. Third, unlike synthetic aperture radar, which is an active sensor capable of imaging through the clouds and night, UNWAYS hyperspectral sensor is a passive system. Sorry. What will be the answer? Go through these questions. Question. Okay. UNWAYS satellite. Question number 7. 7, yes, D. Already we have discussed that it uses the principle of what? Hyperspectral imaging. The hyperspectral imaging means what? Suppose this is UNWAYS satellite. Here we are having sensor. This sensor is what? First is passive sensor. That means what? It will capture the reflected light. Okay. And suppose this is the region. This is the region, and here we have, suppose this is the forest cover region, and apart from that, here what we have? Here we have certain, suppose weapons also. Now this is the sunlight. It captures the reflected. And because of this is called a passive sensor. Now it will capture narrow band of frequencies. It will capture what? This sensor capture narrow band of frequencies we have discussed. And because of this, it can easily ascertain the composition of the material. For example, this forest cover, it will have different frequencies, and inside the forest, what we have this weapon, it will have different frequencies. Now they have already having a chart that this forest cover, the range of frequency will be this much, but inside the forest cover you will get certain different frequencies. That means what? And if those frequencies, if they are correlating with the weapons, that means what? The weapons has been camouflaged over there. Okay. So all the 4 statements are correct. Okay. It's written D. Clear? Okay. Go through this question. Question number 8. It's an analytical one. Please go through it. Question number 8. Yes, if you are having any sort of doubt, please do comment. Solve this question number 8 with reference to the James Webb Space Telescope and its observation of the deep universe. Consider the following statement. Due to the finite speed of light, James Webb Space Telescope captured the cosmic dawn by observing light emitted by the first star as it existed billions of years ago. The telescope is designed to operate primarily in the infrared spectrum because the expansion of space-time stretches the light from the distant galaxies into the longer wavelength, a phenomenon called cosmological redshift. It utilizes gravitational lensing concept. Unlike the Hubble Space Telescope, which orbits the Earth, James Webb Space Telescope is positioned at the Sun-Earth system Lagrange point L2 to maintain a stable cold environment necessary for infrared sensing. Question number 8. What will be the answer? Question 8. What will be the answer? 8D. Okay. 8D. Okay, let us see. We have discussed about the James Webb Space Telescope. Is it? It is positioned at a point called, suppose this is the Sun. Okay. This is Earth. Here we have having a point L1 Lagrange point. This is your Lagrange point L2. So in this halo orbit, James Webb Space Telescope is positioned first point at Lagrange point L2. Now, when you talk about the infrared sensing, it requires a very lower temperature. Since you can see that this is the position L2 point, it is far away from the Sun. Obviously, what will happen? Suppose this is the sensor, it will have a temperature of minus 230 degrees Celsius. Okay, second point. Third, when you talk about the James Webb Space Telescope, we have discussed in the classes that it can monitor what? It is having the capacity that it can monitor your ultraviolet radiations, visible light, and apart from that, when you talk about the infrared, we have the 3 portions: near, middle, and far. So it can monitor this particular region. It can monitor ultraviolet radiations, visible light, near part of the infrared, and middle part of the infrared. In terms of wavelength, it is your 0.6 to 28 microns. 0.6 to 28 microns. Now we have discussed that when we talk about like radio waves and infrared, since they're having longer wavelength, and because of that they can travel longer distance. First thing, we have also discussed the concept of cosmological redshift. Cosmological redshift means what? The radiation, it will be moving from your visible light red towards what? Infrared and radio waves. Is it okay? So it utilizes this cosmological redshift because this James Webb Space Telescope, it is being designed to capture what? Infrared radiations basically. So infrared radiation is what? It's a cosmological redshift. Because an other aspect is what? We talk about the dark energy. Dark energy is what? It's an anti-gravity forces responsible for what? Expansion of the universe. That means what? The two celestial things, they will what? They will what? Expand, and because of that, the radiations, the electromagnetic radiations, they will also stretch and they will move toward the cosmological redshift. That means what? They will become infrared or radio waves. And apart from that, we have also discussed the concept of gravitational lensing. Gravitational lensing, light bends in the presence of gravity. When you talk about gravitational lensing, light bends in the presence of gravity. Bends in the presence of gravity. For example, this is a James Webb Space Telescope. A space telescope, and this is the suppose a celestial object, a star. It is emitting the light. Now this light is not falling on the James Webb Space Telescope parked at L2 point, but due to somehow, if a particular galaxy come in this region, what will happen? The light, it will what? It will bend. It will fall on the optical telescope. That is called your gravitational lensing concept. So all these concepts, they are applicable. So what will be the answer? The answer, it will be your 4. Okay. Question number 9. Let's go through the question number 9. Go through this question. With reference to the proposed India-based neutrino observatory and the nature of the ghost particle, we have discussed that ghost particle means what? We are talking about the neutrinos. We are talking about what? Neutrinos. Consider the following statement. The observatory is designed to be located deep underground to utilize the surrounding rock as a passive shield to filter out background cosmic radiations. Please solve this question. Yes. Question number 9. Nine A, B, C, D. Nine C, 1 and 4. Okay. Other one? 9C. Okay, let us see. Now, we have, suppose this is the underground, suppose this is the rock, and here we are developing what? Neutrino observatory. And here what we have considered it? Here we have, okay, the magnetized iron calorimeter, ICAL. Okay. Now we have discussed that when you talk about the neutrinos, they are what? Weakly interacting particles. They do have masses. Okay, they do have masses. That means what? Higgs boson's particle, it has imparted masses to the neutrinos. But if you go to the standard model of particle physics, the standard model of particle physics has accepted that neutrinos is having mass, but it has failed to explain that Higgs boson's particle imparted mass to these neutrinos. Okay, it is very weakly interacting in nature. Okay, so suppose these are the neutrinos. So these neutrinos, since they are weakly interacting in nature, it can easily enter into this neutrino-based observatory. But all other particles, if we talk about like other particles, we have discussed that neutrinos, since they are weakly interacting in nature, okay, what will happen? These neutrinos are detected indirectly by observing the Cherenkov radiation emitted when they interact the detector medium. For example, these neutrinos, when they will strike this ICAL, the magnetized iron kilometer, what will happen? It's going to release the charged particle muon. It's going to release what? Charged particle muon. This is called muon. And this charged particle muon, it is at this moment, it will be traveling at a speed that is greater than the speed of the light. That means what? It's your Cherenkov radiation. And this Cherenkov radiation is being studied. Okay, so second statement is also what? Correct. Okay, third, the primary scientific goal of Indian neutrino observatory is to determine the neutrino mass hierarchy. Okay, we have electron neutrinos, Mao neutrino, tau neutrinos. Okay, so we will see the concentration of each of the neutrinos. This is also true. And fourth is what? When you talk about the neutrinos, they are weakly interacting in nature. And because of that, they are unaffected by the magnetic fields and can travel across the universe straight line. So all the four statements, they are what? Correct. Clear? Now question number 10, solve it. Question number 10. If any doubt, please do let me know. If you're facing any sort of doubt, if you're not getting any sort of concept, please do comment. Question number 10. We have discussed about the sterile neutrinos. So the certain statement, unlike active neutrinos, sterile neutrinos do not participate in the weak nuclear forces and are theorized to interact with the matter only through gravity. Okay, we have discussed that when you talk about the normal neutrinos, they are very much weak in nature. But when you talk about the sterile neutrinos, they are so much weak in nature that even they cannot interact with the weak nuclear force. Yes, they can what? Slightly interact with the gravity forces. So this statement is correct. While active neutrinos are already notoriously difficult to detect, sterile neutrinos are considered invisible to current underground observatory because they do not produce secondary charged particles or Cherenkov radiations upon passing through a medium. This is also true. Okay. Third statement, recent results from the global experiments like microBonnet have conclusively established that sterile neutrinos are the primary constituents of the universe dark matter. No. Why so? Because when you talk about the sterile neutrinos, they are sterile in nature. It is very difficult to detect. No doubt. We have I have taken in the classes that these sterile neutrinos, they seem to be the component of dark matter, but still it is not being decided. Okay. If they exist, sterile neutrinos could explain the reactor anti-neutrino anomaly by accounting for the missing flux of the active neutrinos during nuclear oscillation. This statement is also correct. So it will be your 1, 2, and 4. 1, 2, and 4. Question number 11, solve it. We have discussed about the quantum dots. Question number 11. With reference to quantum dots, which are the semiconductor nanocrystals, consider the following statement. Solve it. Please solve this question. See, when we have discussed about the quantum dots are what? Zero-dimensional nanoparticles, and these quantum dots, they are being generated from the semiconductors. Okay, these semiconductors like cadmium selenide, it has to undergo the process of nanoscale processing, and because of that, quantum dots are being created. Now, one of the peculiar and important property of quantum dot is what? If the quantum dots are being prepared from the similar material, but they are differing in size. What will happen? Because of the difference in the sizes, they will have different optical and electronics properties. And the other aspect is what we have discussed when you talk about the quantum dots. If the quantum dots are being made from the similar material but of different sizes, they will give different colors. A smaller one, it will give what? Violet color. Larger one, it will give red color. We have discussed in the classes. Okay. So here, what is the question? Here you can see that The unique optical and electronic properties of quantum dots are the result of quantum confinement, where the movement of electrons is restricted. I have discussed this is also true. The color what we have discussed, get the fluorescent color, this is also true. In medical application, quantum dots, it can be used, for example, MRI. Quantum dots, it is what biocompatible in nature. That means what it can be introduced in our body. If we talk about the MRI, these quantum dots can be injected so that what it can identify if there is any sudden changes, if there is tumors or something like that. True. But when it comes like that, unlike traditional LED, quantum dots based displays rely on the physical vibration of atom. No. This what? Quantum dots, they rely on what? Photoluminescence. Photoluminescence. That means what? This is the quantum dots. If in the quantum dots, what will happen? If in the quantum dots, ultraviolet light will strike, electron will move to the higher orbit. Again, electron will come back to its ground state. It will release fluorescent color in the visible light. And this phenomenon is called what? Photoluminescence. So this statement is what? This statement is wrong. Yes, yeah, electroluminescence. Very good. So, answer will be your 1, 2, and 3. Okay. Now, question number 12. With reference to the nanoliquid urea recently promoted under the Atmanirbhar Bharat initiative, consider the following statement. We have discussed in detail regarding the nanoliquid urea. Solve it. So, unlike traditional urea where nitrogen is primarily absorbed through the soils in the nitrate and ammonium ions, nano urea is applied to a foliar spray and is absorbed directly to the stomata. Yes, we have discussed that when you talk about the conventional urea, okay, first of all, it is only 30 to 33 to 35% effective, and apart from that, when it is being sprayed, it will get dissolved, it will move into the soil, and what will happen? Urease enzyme will come into picture, and those urease enzyme, it will convert your urea into ammonia, and finally, after when it interacts with the water, it will become ammonium ion, NH4. And when this ammonium ion with the help of nitrogen fixes in bacteria, like rhizome bacteria, it will get converted into your nitrite and nitrate. Nitrite plus nitrate. Okay? Nitrate. So these are the three formats. But when you talk about the nanoliquid urea, since nanoliquid urea, they are spread over the leaves. So ultimately what? They do not have to move into the soil. If they do not have to move into the soil, that means what? Your rhizome bacteria, nitrogen fixation bacteria won't come into picture. So this will absorb, this is being spread over the leaves and they are being absorbed into the stomata. Now in the leaves itself, we have urease enzyme, and because of that, only this nanoliquid urea, it will be absorbed using what? It will be absorbed through ammonium. Okay? This won't get converted into nitrite and nitrate because since it is not into the soil, it won't get converted. Okay? Now, second statement. In terms of efficiency, nano urea has significantly higher nutrient uses. This is also true. Third statement, while neem coated urea specifically aims to reduce nitrification and leaching losses in the soil, nano urea reduces the overall environmental footprint by minimizing the volatilization of ammonia into the atmosphere. This is also true. Okay, we have seen that when we are applying the normal urea, those urea, it will get changed in the ammonium with the help of urease enzyme. The ammonia is what? It's a gas, and because since the gases are volatile in nature. Okay, but you can see that when you talk about the neem coated urea, what it will do? It will slow the rate of dissolution so that what? Only minimum amount of ammonia is being released, and those minimum amount of ammonia that will get converted into ammonium and finally into nitrate and nitrate. But these things what? It's not applicable in the case of your nanoliquid urea, because when you talk about the stomata, they will absorb this nanoliquid urea, and after that what? They will automatically get converted into ammonium ion, and finally they will get converted to ammonia gases, and quickly it will get converted into your ammonium ion. Okay, so this is also true. Third statement, the widespread adoption of nano urea is strategically intended to reduce the India's fertilizer subsidy burden, true, and decrease the logistical pressure on the primary transport infrastructure, railway and warehousing, because you can see that now one bag of urea, if you talk about the one bag of urea that contains 45 to 50 kg of urea, that can be replaced with what? With half liter of urea. So all the statement they are correct. All the statement they are what? Correct. Okay. Question number 13. Solve it. We have discussed about the metal organic framework. It was being awarded Nobel Prize in Chemistry in 2025 itself, and it seems to be very much important question. Please solve this question. with reference to the metal organic framework, which are often described as molecular sponges, consider the following statement. So, metal organic framework are hybrid crystalline materials composed of inorganic metal nodes coordinated with the organic linkage molecule to form a highly porous multidimensional structure. That is true. What? MOF are hybrid crystalline material composed of inorganic metals nodes and that are being joined with the help of organic ligands. Okay. Now, when you talk about MOF, one of the exceptional characteristics is what? First is your high surface area. High surface area, and the second is what? They have high porosity. They have what? High porosity. When you talk about the porosity, that means what? Porosity means what? They can absorb what gases. So, high surface area first is, and other is what? High porosity. Okay, so with this we will see the exceptional high internal surface area of MF allows them to store gases like hydrogen, carbon dioxide at much higher densities than the conventional higher pressure tanks. True. Question number 3. Unlike traditional catalyst, the chemical properties of MOF are tunable, meaning the pore size and chemical affinity can be precisely engineered. Tunable means what? We can change the pore size and all those things. Fourth, a significant application of MOF in arid region. Arid region is desert. In the desert also what? This is a problem of what? Potable water. So what we can do? We will take this MOF. Since this MOF, they are having higher surface area and apart from that higher porosity, they can what? Collect the water molecules. And from that what? We can get the water. This statement is also what? Correct. So all these 4 statements, they are correct. Okay. Now question number 15, solve it. 14. Solve this question number 14. Okay. Gamma ray bursts are the most powerful electromagnetic explosions in the universe, typically associated with the formation of black hole during a stellar collapse or neutron star merger. We have discussed that when I was discussing the black hole, there I have discussed that if you talk about the electromagnetic radiation, the higher, if you go towards X-ray and gamma ray, X-ray and gamma ray, they are having higher frequency, and because of that, they will be relating to what? Higher energy itself. So obviously X-ray and gamma ray, they will be released into the universe whenever there is a highly energetic process. For example, black hole formation or neutron star, merging of neutron star. So this statement is correct. This statement is correct. And we have also discussed about the tidal disruption event. For example, suppose this is a black hole. This is a black hole. Okay, and this is your event. This is event horizon. If in the vicinity of black hole, there is a star, this is a particular star. If it comes under the gravitational influence of black hole, the complete star won't be sucked up into the black hole. Rather, what? 30 to 45% of the star material. 30 to 45% of the star material. 30 to 45%. That means what? When you talk about the star, we have a core, and on the outer side, what we have? Plasma-like structure, gas-like structure. Those 30 to 35%, they will be ejected out and they will start moving around the. They will form the accretion disk, and finally what? They'll merge into the black hole. So the illumination that is being created, this is called your tidal disruption event. Okay. The tidal disruption event occurs when the gravitational pull of a supermassive black hole threads a nearby star, resulting in the characteristic flares of multi-wavelength radiations. True. Extreme nuclear transients represent sudden and massive surges in the luminosity of a galaxy center, distinguished from a regular active galactic nuclei by their non-periodic and temporary nature. This is also true. Unlike gamma ray bursts, which are characterized by the brief flashes of high energy transition, tidal disruption event provided a long-lived afterglow that can be observed for months across X-ray and gamma ray. See, there is a difference when you talk about the gamma ray. Since they are highly energetic process, they can stay for milliseconds to what? Certain minutes. But when you talk about this tidal disruption event, the light, it can exist for what? For days. So this statement is also what? True. So your answer will be your D, 1, 2, 3, 4. Now question number 15. Read the question number 15. With reference to the Indian Astronomical Observatory at Hanle, Ladakh, consider the following statement regarding the selection and maintenance of ground-based telescope. We have discussed the different factors. Long lived means what? Suppose when you talk about like gamma ray burst. Okay, so gamma ray is a highly energetic process. For example, consider the formation of black hole. Okay, after supernova explosion, what is being left? the core is being left. Since the size of the star is very much higher, what will happen? It will easily cross electron degeneracy pressure, neutron degeneracy pressure, quantum quark transient and finally it will get converted to black hole, and because of that gamma ray burst it will be there. Okay, so because of that this gamma ray it will be applicable for milliseconds to minute. But when you talk on the tidal disruption event, it's a slow process, and because of that the illuminations it will exist for days to hours to days, and this is called your long lived. Is it okay, Sneha Silfa? Okay. Question number 15. With reference to the Indian Astronomical Observatory in Henley, Ladakh, consider the following statement regarding the selection and maintenance of ground-based telescope site. So we have to see the different factors that is responsible for the development of ground-based telescope. Solve it. Question number 15. We have discussed the Ladakh. When you talk about the Ladakh, it is the best site for the development of ground-based telescope. Why? First of all, we have discussed that due to the presence of water molecules, they are responsible for absorption of infrared. When you talk about the Ladakh, it is what? It's a cold desert. We do not have the water. Second is what? Light pollution is very much less. So obviously light interference problem it won't be there. When you talk about the Henley, it exists at around 4,300 meters above the mean sea level. So considering all these facts, it is what? It is important ideal site for the development of ground-based astronomy. So the rain shadow location of the Ladakh plateau ensures low precipitation, water vapor, which is essential for absorbing the infrared and sub-millimeter wavelength. Okay, true. Because water, they will absorb the infrared radiations. High altitude sites are preferred because they reduce atmospheric column. Okay, so high altitudes, why? So that low atmospheric disturbance. This is also true. Arid climate like Henley provide a high clear night fractions, maximizing annual observation true. At the preserve of dark sky. Okay, this is also true. So all the four statements they are correct. Now question number 16. Solve this question number 16. Why is the Sokar Valley in Ladakh considered as ideal analog site for the HOPE mission? We have discussed about the HOPE analog mission. Because see, HOPE analog means what? Analogous means what? Basically, we are carrying out this HOPE analog mission so that we can exactly see how our astronauts will behave, stress, how our astronauts they are going to live on the Mars or they are going to live on the Moon. This so very, its geological area, its geographical area, environmental conditions are similar to that of the Mars and Moon's condition. That means the atmosphere is very thin over there. So its geology, low oxygen level and cold desert environment closely mimic Mars and Moon's condition. Question number 16. Okay. Question number 17. Go through the question number 17. Question number 17. Sunbird concept. We have discussed about the Sunbird concept. A nuclear fusion powered rocket. Consider the following statement. Unlike the traditional nuclear thermal rockets which uses fission to heat the propellant, Sunbird utilizes a direct fusion drive where the plasma forms the fusion reaction is used directly for the thrust. That means what we have discussed that when you talk about the Sunbird, it will be using the concept of direct fusion drive. That means with the help of fusion reaction we can the fusion reactions it will be used as for the purpose of propelling the aircraft, propelling the spacecraft. Along with that, electricity also can be utilized. Electricity it can also be generated. The first statement is correct. Second, a fusion powered rocket is analytically superior to chemical rockets because it offers both high thrust and high specific impulse. This is also true. Third, the Sunbird concept primarily relies on the deuterium-tritium reaction because it is the only fusion process that does not produce harmful neutron radiations, making it safer for human use. What will be the answer? 17C. Okay, 1 2, because here you can see that it uses what? Helium 3 plus deuterium. Okay, this statement it will be incorrect. Such rockets are dual-use system capable of providing megawatts of electrical power to the spacecraft life support system while simultaneously providing the propulsion system. There we have discussed it will what? It will be helpful in propelling the spacecraft as well as what? It is going to generate the electricity, and those electricity it will be what? Useful for the purpose of payloads. So here answer it will be 1 to 4. Question number 18. With reference to the Bikram 1 launch vehicle developed by the Indian private sector, consider the following statement. Solve it. Question number 18. Question number 18, solve it. With reference to the Bikram 1, okay, first, unlike PSLV, which uses a combination of liquid and solid stage, Bikram 1 is a multi-stage solid propellant rocket designed for what? Rapid deployment. Is it? So, when you talk about like polar satellite launching vehicle, we have discussed that the polar satellite launching vehicle, it comprises of 4 different stages. First stage solid propellant, second stage liquid, third stage solid, fourth stage what? Liquid. But when you talk about this Bikram, it comprises of 4 stages. The first 3 stage, it will be what? They will all have solid propellant, and finally we will have what? Liquid propellant. And here this liquid propellant, we have this private company, it has indigenously developed an engine. What is the name of the engine? Here the engine that is being used for the purpose of what? Utilizing this liquid propellant, it's called a Raman engine. And this Raman engine, it is being developed using the concept of what? 3D printing. 3D printing, is it okay? And this 3D printing, it uses a material called carbon fiber. Carbon fibers. Let us see if we can solve this question. This vehicle utilizes carbon fiber based composite structure as 3D printing engines, significantly reducing the overall mass and increasing the payload to weight ratio. True. Bikram 1 is specifically optimized for ride-sharing missions capable of placing multiple small satellites in different low orbit. True. Kalam 100 and Raman engines series are indigenously innovation that allow the vehicle to be assembled and launched within 24 hours. This is also true. See, for example, when we are using this 18A4 is wrong. Which one? No, this is also correct. For see, when you talk about, like for example, when you talk about the polar satellite launching vehicle Vikas engine, for the purpose of construction of Vikas engine, it will be taking around 20 to 25 days, suppose, assembly. But since, see, go through the question, where we have discussed that when you talk about the Bikram 1, it uses what? 3D printed engine called Raman engine. So when you talk about the 3D printed engine, 3D printed objects, it can be developed very fastly. Just we have to develop the we have to develop the structure with the help of AutoCAD, and finally just we have to give the command to the 3D injectors machine, and the engine it will be developed. And because of this is the statement. It can be launched within 24 hours from the mobile launch. Okay. This is also statement is correct. So the answer will be what? 1 2 3 4. Okay. Question number 19. Read the question number 19. Yes. Question number 19. Okay. Read it. With reference to the India lunar explorations of Chandrayaan-3 mission, consider the following statement. Unlike its predecessor, Chandrayaan-3 adopted a failure-based approach. I have discussed that with the failure. For example, Chandrayaan-2 failed because its lander, it was having got 5 legs. So in Chandrayaan-3, we have what? Center leg is being removed. Now it is having got 4 legs. Apart from that, the selected site, it was very much smaller in nature, 500 meter into 500 meter. But in the Chandrayaan-3, the selected region, it was 4.5 to 2.5 kilometer in range. Apart from that, we have also reduced the descent speed also, and because of that, Chandrayaan-3, it's called a failure-based approach. Okay, failure-based approach which included the removal of central thruster and the expansion of the potential landing area. True. Second, the mission propulsion module carried the SHAPE payload, which is designed to study spectral and polymetric signature of the Earth to identify the habitable exoplanet. True. The Pragyan rover confirmed the presence of sulfur near the lunar south pole that provides critical insight of the moon's volcanic history and primordial cluster composition. True. Chandrayaan-3 utilized the existing, obviously, we have, when you talk about the Chandrayaan-3, it has utilized the Chandrayaan-2 orbiter itself. So this is also what? True. All the four statements, they are correct. D answer. Read question number 20. Sneha, see here. Here it is written multi-stage. Unlike a PSLV which uses a combination of solid and liquid, Vikram 1 is a multi-stage solid propellant. Multi-stage, I have discussed that at 3 stages. First, second, third, it comprises of what? Solid propellant. And finally, we have what? Liquid propellant for the Raman engine. So, is a multi-stage solid propellant. Okay, designed for rapid deployment. This statement is true. That if the statement becomes Vikram 1 only has multi-stage solid propellant, then that statement it will be incorrect. Is it okay? Okay, question number 20, go through it. Question number 7. Question number 20, with reference to the India's second spaceport at Kulasekharapatnam, consider the following statement. We have discussed about Kulasekharapatnam. Is it? So, there what we have discussed, suppose, here we have what? Sriharikota launching station. So, this Sriharikota launching station, it is closest to the equator and on the east coast. So, definitely here, if you go for the geosynchronous mission, if you go for the geostationary transfer orbit, okay, geostationary orbit, we will get the initial thrust. But if you are going for the polar mission, we are not getting initial thrust. Apart from that, when you go for the polar mission, okay, this is Sri Lanka, we have to what? Go for this dogleg maneuvering. And because of that, what we have developed? We have developed this Kulasekharapatnam. This Kulasekharapatnam is being developed so that what? We can go for the polar mission. It is meant for the small satellite launching. Second point, and apart from that, yes, we can go for your geosynchronous mission also. We can go for the geosynchronous geostationary orbit. But here also what? We have to go for what? Dog-leveling maneuvering. Here we have to carry this distance. And suppose this particular distance, if you talk about this particular, there is a strong possibility that the rocket can burst over there. The rocket can collapse over there. And because of that, we have to go for this dog-leg maneuvering. So when you talk about like Kulasekharapatnam, it has basically been designed for the purpose of what? So that it will basically be designed for the polar mission. Okay, so go through the questions. Its geographical location allows the direct southward trajectory into the sun-synchronous polar orbit, eliminating the need of dog-leg maneuvering. True. The facility is specifically optimized for small satellite launching vehicles and is intended to be used by both ISRO and non-government entities. True. Unlike Sriharikota, Kulasekharapatnam is situated west of Sri Lanka, which prevents the rocket from flying over the foreign land masses. This is also true. Fourth, being closer to the equator than Sriharikota, it provides a significantly higher velocity boost for the satellites being launched into geostationary transfer orbit. Question number 4. Being closest, we have discussed it when you talk about the Sriharikota, its latitude is around 14 degrees, something like that. But when you talk about the Kulasekharapatnam, it is around 8 degrees, something like that. Since closest to the equator, it provides a significantly higher velocity boost for satellites being launch, this statement is wrong, because when you talk about Pulasekharapatnam, it is somewhere in this particular region, so it is at the west coast. It is at the west coast, and apart from that, we have discussed that to gain the initial speed, to get the initial thrust, it should be on the eastern side. For example, suppose the Earth rotates from west to east. Okay, so this is the Sriharikota. This is the rocket. So obviously, at this point, it is going to get the benefit. But here, it is located on the western side, a bit on the western side. So here, what we will won't get the initial boost. No initial boost. No initial boost. Okay, yes, it is closest to the equator, and apart from that, since land masses are there, this statement is incorrect. So we have what? 1, 2, 3. 1, 2, 3. Is it okay? So see, this is how the, if these are all the analytical based questions, and all this type of questions we have discussed in the classes. I have another 20 questions, but you can see that the time is 5 p.m. itself. So the next 20 questions we will be discussing in some other day itself. So with this, thank you. Thanks a lot, everyone.